Okay, I'll just do a quick draw a slab and let's flatten it with the machine. So if you want it to be an automatic operation, we'll go to SolidWorks and draw the part. Close that and go to File, New, Part. Okay, and we'll sketch your slab with this rectangle on the front plane. And this is kind of 0, 0. X-axis is this way and Y is this way. You can see it right down here. So we'll just draw a rectangle and then make this line 10 inches and this line 40. So now we've got a 2D drawing of your slab. And at this point we go to the Features tab, Extrude. Let's say we'll go to 2.5 inches. Okay, so there's our 3D model of our slab. At this point we need to save as slab. Okay, then we'll go Tools, SolidCam, New, Milling. And check it as an external part right here. Alright, so what we don't have set up is the coordinate system, the stock, and the target. So we're going to click coordinate system. And on a simple part like this, let's say we want this to be X0, Y0, Z0. So we'll select this face and see if it automatically defines it there. And it did. Okay, so we're happy with that. And we check all these boxes. And so now we have a target and a coordinate system. We need to set up the stock. So stock, generally if you just select the part, it'll put this green bounding box around it. And then these values here are the amount of material basically that's extra. So we'll just leave it there. Let's say Z plus has 0.15 inches extra material. That's along this blue axis vertically. And check the box. Okay. Okay, so we have a part defined, which is this slab with our coordinate system set up. And so you just right click on operations and add a milling operation, and then for slabbing the face, we'll go to face. And the geometry on a face operation is basically based on the stock, or you can select part of a drawn stock, but we want the whole thing. So we'll select this guy, choose our tool. It's end mill. And these tools will be, you can save them for future use, so you don't have to do this every time, but our diameter is 2 inches. And it will auto-populate reasonable values in all this. And check the box. Levels. So the upper level is 0.15 based on the extra stock we have. And the depth is 0.15, leaving a delta of 0. If you want to do equal step downs, you can do it here. You could say 0.075, and that would do 2 passes, 75 thousandths deep. But we don't want that. So the technology tab here, you can do a hatch. There's a little preview. You can do a hatch, a contour, a loop, sharp loop. Oops. We'll just do a hatch. And then you can choose the cutting direction, zigzag, or one way it would cut one direction and then rapid back, cut that same direction if you're worried about tear outs or something. You know, extensions beyond the slab with your tool, etc. So link will have ramping. Ramping doesn't really apply to cutting a slab because the tool will start off of the part, you know. It's not plunging in any way. And so, oh, this is a big one. So on the hatch or any toolpath, you can choose the percentage of tool diameter. So this will overlap the last cut by 30%. You could say 1% and it would barely, you know, it would cut almost full width, if that makes sense. But 30% to 60 seems to be a good number. And that's about what you need. So you click this Save and Calculate button. It looks like we ended up with 2 levels there. That blue line is the toolpath. But let's see what we got here. There we go. So that step down box is enforced even with this unchecked. So we want a 0.15 step down. We'll save and calculate. And that looks roughly right. So one thing I like to do is right click on operations and SolidCam Simulator. And it will simulate the toolpath. There's our tool. We can go nice and slow here. So you can kind of watch it and see if anything unexpected happens. And there's our toolpath. Do it one more time. That looks good. We don't see any ridiculously high Z moves or unexpected plunges. You can also simulate with this one. Let's say solid verify, and that will do a more primitive simulation. That one will simulate with the toolpath shown. But regardless, okay, so now that we've got our toolpath happy, we right-click operations, G-code all, and then generate. Let's name it slab and save it to the desktop here. This program here will show up. That's the G-code for your toolpath. Oh, and I see a mistake I made. So G1Z0, that will move Z to the 0 position at the speed F12. And then these are all in the G1, so they're enforced by this feed rate number. And I would like the feed rate to be higher, so let's modify the feed rate. So we'll double click our operation here. We'll go to Tool, select, and then this feeds and speeds button here, cutting conditions. We'll go, you can feed by inches per tooth. So this, at this setting, it would cut 0.006 per tooth. But I like to go feed XY. Let's try 200. This will be your finishing speed, so let's say 80, but that won't apply to this job. There's no finishing pass. And the Z will move, let's say, at 16 inches. And we'll select the tool. Save and calculate again, because we changed some things. And then generate the code. And overwrite it. So now you can see if the Z axis feeds at 16, and all these X moves are the cutting moves. These Y moves are basically feeding at as fast as you can go, or 400, because they're off of the slab. They're not a cutting condition. So we like that. We can just close this and minimize this guy. And here, I'll just close Mach 3 and see what that looks like for you. So we'll choose Mach 3 mill. And then load G-code. And there's slab right there. And you can see, I'll zoom in a bit. You can see a preview of what that looks like. And here's our code in this window. And at this point we move our machine with the arrow keys. So the center of the tool is kind of on that corner we chose. So say we're happy right there. For the X and Y position, we'd 0 X and we'd 0 Y. And then, I'll just get the... And that's roughly 0Z. Oh, I was really close, a 10,000th of an inch, not bad. So at that, let's 0 the Z2. And at that point, I like to move my tool up out of the way with the keyboard and start the spindle, which will be in the following video, and off we go.